Hello, everyone. Thank you for joining the webinar on the subject of WOMT 101, popular technologies, thermal technologies, which may not work. And I think there will be more people joining, but I'd like to start on time, so we'll proceed. I prepared a little agenda for this webinar, and in the intro part, I'll start this whole presentation with a shocker, with a really, really bad example of what some companies do. And then I'll briefly introduce myself and HEMAX. And I'd like to also explain to you about the virtual assistance program that we started since the COVID hit the world. And in the second part of the presentation, we'll talk about the thermal performance related information. And there I'll talk about reflective technology, PCM, active heating, microfibers, hollow fibers, sound feather, and so on and so forth. And I'd like to also talk about the real life warmth versus what you might believe as a real good performance. So I'll touch base on that as well. And the third section is going to be environmental related, but this part I'll cover more extensively tomorrow during the YouTube live streaming. And you can do the keyword search, a Clean Recycling Initiative, or send us an email if you need a link. We're going to talk about the greenwashing that's been happening, and you will have a totally different perspectives about recycled or recycling or biodegradable or garment recycling, etc. So if you can spare your time tomorrow at 2 p.m. Eastern, please join us because this is going to be a very important discussions. And then number 4, we're going to talk about HEMAX technologies. I'm not going to cover spend too much of our time today on this section because there is a lot to cover, and the 1 hour is certainly not enough to cover this. And then Q&A. If you have any questions during the presentation, please use the chat box. My colleague Kyung-Yeon will keep tally of the question and answers and then address it to me. Now, before we go further, I want to share with you a perspective that I have. Now, thermal technology, if you look at your closet, for example, everyone, if your microphone is on, please can you mute it? Because I can hear some of you talking in the background. Anyway, I'll continue. Can you write a message on the chat box? So if you look at your closet, the most bulky items are actually thermally insulated. And even the cost-wise, buying a winter jacket versus a shirt or underwear, there is a large difference in cost. In fact, some of the most expensive items are those that have thermal technology, so winter boots versus sandals, for example. But if you think about it, I took textile engineering in Korea, but thermal technologies was not a part of the curriculum that we were offered. And I looked through the curriculums of a lot of different fashion schools and textile engineering schools all around the world, but I could not find any valid program that teaches seriously about thermal technologies. So why is there a big gap between the reality of how much we spend on these items versus the education part of it? Maybe this is the reason why some of really, really bad things are happening. And I'm asking, is this for real? One program that we have is, there is a big fashion company that says, oh, here we have a clothing donation box in our stores. Please bring your garments that you don't want anymore. We'll chop it up and use it as an insulation. And when I saw this campaign, I could not believe myself because basically they're saying they put through the the garment chopping or slicing, cutting, and use that as an insulation material. But insulation is not a whole bunch of chopped fibers or even dust. If you look at a properly constructed insulation material, once again, this is not a collection of dust or chopped up fibers. So this could not be wrong in the perspectives of thermal insulation technologies. But what about this then? Can you guarantee that people will clean only the items that do not have microorganisms living in there? In fact, there has been manifestation of dust mites in Montreal, where I live, and I would not be comfortable with a company collecting garments from these cities and create insulation material that can have living organisms like this. And they, in fact, one of the marketing advertisement that I saw from that company is they say we'll select suitable material and turn it into insulation material. Now, when consumers see this, they may think, oh, they will select it, meaning that they will go through it. But can you see bed bugs? No, you cannot. They didn't certainly mean that, oh, we'll put each of these garments and go through each section of the garment and make sure that there's no microorganisms. No, that's not a possible process. So a lot of times I feel like we are put in a position where we have to do this research and protect our interests. Now, why do consumers have to be put in this situation? I'm sorry. I'm sorry. So why do we have to be like, even if it's not a textile item, we're consumers of a lot of different stuff. It can be medicine, it can be furniture. Do you want to be in the position where you have to do research on health effect or performance features in everything that companies claim? Therefore, who has to take on this responsibility? It's the companies, people like us who are in the industry. We need to do the proper job. Unfortunately, there have been a lot of issues that I see in the industry, that the wrong technologies are presented to the customers without a proper explanations and things like that. So today, hopefully we can go through some of these and then you can have a better understanding of thermal technologies. So I want to put a little bit of validity of what I am presenting today by explaining to you about my credentials. I'm managing HinMax Worldwide, and recently I established a nonprofit organization called Clean Recycling Initiative, and I'm a textile engineer by trade. And before I established HinMax and Clean Recycling Initiative, I was the sales manager for 3M, Tinsolate, Scotchlite, Scotchgard, and I created and invented all of the products and technologies under HinMax brand. And also Clean Recycling Initiative was created by my own hands. And I have LinkedIn profile. I'll send you the recording and PDF file after this presentation. Hopefully you can connect with me through LinkedIn. HinMax is based in Montreal, Canada, and we specialize in thermal insulation material, and we have subsidiary structures in Korea and China. And we offer 8 different product categories, and despite of the short history of HinMax, we have been recognized by ISPO Top of Innovation Awards in all of our product categories. That's because we use the real science. We do things right. and I'll explain to you briefly towards the end of our presentation the different approaches that HeatMatch has taken compared to other players in the market. Before we go to the real fun part of dissecting different technologies, I want to explain to you that we offer a COVID-19 virtual assistance program. So several large brands have felt that they needed to educate their staff more with thermal insulation or thermal technologies in general. So we've offered online meetings with their staff, and sometimes we do these things for sourcing or marketing purposes. And basically, any industry segment that has something to do with the thermal technologies and whatever job functions you may be, even those who are just interested in dealing with the cold winter climate, you can take advantage of this program, and it's an ongoing program. So let's get into the technologies that are out there that people may have misunderstanding and wrong information. And the first one is reflector. There has been one particular company which has been massively successful with this reflector idea. Basically, the idea came from one of 5 different ways of our body losing heat. In the next webinar, I'll go through each of the different 5 ways in more details, but basically this reflector idea is addressing the radiative heat loss that our body has. So the idea is that the radiation that comes out of our body is reflected back to our body, so it conserves the heat rather than losing it. But then, is there anybody who is brave enough to wrap your body around with a piece of aluminum foil and go out in winter weather? I don't think anybody would do that. Why? Because it doesn't work this way. Now, radiative heat loss, I don't know why this word is so difficult for me today to pronounce, but radiative heat loss happens more when you are in a vigorous activity. And in fact, you can feel this after you have a really vigorous workout, that you can put your hand in front of your forehead and you can feel the heat coming out of your body. Especially when the weather is hot around you, you will feel more because your body is built to try to get rid of the excess heat as quickly as possible. Usually that is not the case in this type of environment. However, somebody who has studied this and say, look, even if it's in a really cold environment and you're not doing any vigorous activity, still radiative heat loss is a part of how you lose your heat. Therefore, this reflector technology works, maybe not really effectively, but it still helps. That would be valid only if you don't understand this. So this chart is a thermal conductivity chart. So we around us, there are so many different types of materials. Non-metallic solids and the pure metals have some of the highest thermal conductivity. That means the higher thermal conductivity it passes the heat around much, much easier. So when you have actually this type of material close to your body, it will dissipate your body heat much, much quicker. So that goes against the whole idea of thermal technologies that needs to conserve the heat energy as much as possible rather than passing it around as much as possible. So that's why this does not work. In fact, if you live in a house or a building where the traditional radiator is still present, then you can put a piece of aluminum and then put your hand on top of it and see how you feel. if that reflector technology works in the thermal technologies. So this is one technology. And also, if you look at it, it is always used with conventional thermal insulation material. Why? Because it just doesn't work to the level that that you may understand. PCM. Now, it sounds really like a rocket science. In fact, a lot of people have this perception of PCM like a really difficult technology, because a lot of times I see companies that promote this PCM mention that the NASA uses it as a part of astronauts' uniforms. So that a big perception is coming from that. So let's dissect this technology a little bit here. PCM, although the name may sound really high-tech, it's really not high-tech. Most common PCM material is water around us. And also ice pack that you use when you twist your ankle, it is in solid form in the freezer, but then when you put it on your ankle and it slowly turns into a liquid form. So that is a phase change. And one of your favorite PCM might be an ice cream. You can basically see the phase change happening before your own eyes within 5-10 minutes of you enjoying the ice cream. So that is the PCM. So if you look at the water as a PCM material, before it reaches 0 degrees Celsius, it is basically in a solid form, and it's ice. And then phase change occurs at 0 degrees Celsius. Until it fully melts, it maintains that temperature. And then it becomes a liquid. And then it will have another phase change occurring at the boiling temperature. So this is a phase change material. So this was me in 1997 before I immigrated to Canada. I clearly remember because I was, it was really hot summer, and we didn't have the air conditioner in our apartment unit. So I tried to cool the air around me with ice. But if I used only a very small cubes of ice, it would not last too long. Whereas if I use a big block of ice, it would last much longer. So PCM, what's really important is how long does it last and at what temperature. So let's say we apply this idea to winter clothing, okay? Winter, whatever textile goods that you might have. So the important factors that we have to consider is at what temperature does it activate? Because if PCM material that somebody says, oh, we have PCM material, but if it activates at 5 degrees Celsius for 5 minutes, then that's not really a good material for the winter garments. And also quantity, based on how much you apply, the duration will be determined. So how long is it going to give you the relief from the PCM state? And durability, is it going to stay on the garment after a few washes? So durability is also very important. And the cost aspect of it, and also environment is a chemical material. And if it leaks into our rivers and ocean system, then the environmental impact is something that we have to consider. Now, in all of the companies that claim the functionality of PCM, I have never seen anybody detailing these information. So without this information, I have no idea how much relief I'm going to get at what temperature, and is it going to stay in the garment? So just claiming PCM, oh, therefore it's good, it doesn't paint the picture properly for the consumers. So invariably, you will see PCM material always use the conventional thermal insulation material because it relies on the thermal insulation, much like the reflector. And the active heating, this is more honest and straightforward application. Basically, you have electric power heating, and it relies on battery power, of course, and also it traditionally it was relying on the wired applications, but the technologies have been evolving, and I see some other technologies more recently. But we also have to think about environmental impacts and wash durability, if it's printed or sprayed, etc. So once again, invariably, this will always use in combination with conventional thermal insulation material. So up till now, three items that we covered, the reflector and the PCM active heating, I call them unconventional heating thermal technologies. I have been mentioning that the conventional thermal insulation material is always used in combination with these. Now let's look at the conventional thermal insulation. So this, I call it a passive heating rather than active heating that we saw in the electric thermal technology. It uses our body heat as the energy source. It stores body heat in air pockets of thermal insulation material, and there are some important variables to remember. How efficient is the material to provide a structure to store maximum quantity of drier air in an efficient way? Now, the reason why I say dry or drier air is, once again, this thermal conductivity chart. As the humidity increases from the 0% humidity to 100% humidity of water, thermal conductivity increases exponentially. Therefore, wet air inside thermal insulation material is not as efficient as drier air. And when I say efficient way, now, if the quantity of air is the important factor, and if that's the only important factor, this kind of bubble wrap would be a good insulation material. Once again, is there anyone who's brave enough to experiment this? You wrap this around and go outside in cold winter weather. Would you expect yourself to be warm? In fact, I've tried this, it doesn't work, so you don't have to try. This is what I mean by efficient way. Although there is an abundance of air, dry air inside the bubbles, it is not efficient. And I'll cover why it is not efficient in this example of big air channel. This is not the official name. I don't know what this technology is called. Lately, I have been seeing this type of insulation more and more. In fact, one global brand is advertising this as an intelligent insulation. And basically, it creates a huge channel inside the fabrics, in between the fabrics. And basically, it's an air tunnel that is there. Now, this idea, I'm sure, came from the knowledge that we have that air is one of the most efficient in terms of thermal protection. And but if you look at this insulation R value, the airspace with a 3.5 inches thick, it gives you R value of 1.01. Now R value, I'll explain it to you with this graphic here. R value is similar to CLO. In the textile industry, we use more of a CLO. What it is that it's a simple conversion between R and CLO. Usually CLO value is 1.1 multiplied by R value. So it's 10% higher value, CLO. So if you say that airspace of 3.5 inches thick is 1 R value, if you convert that into CLO value, it becomes 1.1 basically. And if you look at the claw value of a average, of course, there are all kinds of different materials and thickness of the suit material and everything else. But if you use average material of a man's suit, and if you measure the textile goods, the claw value of the textile goods of all the components, then it becomes 1.0. Okay, so that way you can have a little bit of measuring stick in your head. Now, airspace with 3.5 inches thick, that means about 7 centimeters in metric system. 7 centimeters is pretty thick, but that gives you 1.01 or 1.1 claw value. And let's look at how claw is measured. So basically there is a heat plate on the bottom, and there is a, you can cut a fabric and put it on top of the heat plate, and basically you raise the temperature to your body temperature, 36.5 degrees Celsius, and then you measure the temperature of the air above the sample. So the difference between the T1 and T2 becomes the thermal efficiency of the material that you're measuring. So that's how you test the claw value. And you can have in the form of thermal foot, thermal hand, thermal mannequins. But basically, it's the same principle. And the measurement unit, usually in apparel industry, we use claw. And in the home textiles, we use TOG, and constructions, R value. So, but they're interchangeable. And it's a simple conversion factor that you apply to calculate between claw, TOG, and R value. So going back to this image that I showed you earlier. Now, if you look at some of the lowest product categories that we offer in Heatmax, let's say 80 GSM basis weight, the thickness is, you can see, thickness you can see is only 1/10 of 3.5 inches, but our claw value is more than 2 times of the R value. So when the air is by itself, it's not a good thermal insulation. That's what I'm trying to say. You have to have a proper structure of, in order for you to be, to have a good thermal value into it. So this also came from a very simple idea of, oh, air is a good thermal insulation material. So I'm going to maximize the presence of air. But once again, it doesn't work. That goes against the efficiency part that I mentioned before. Now, this might be an eye-opener for a lot of you guys who think that some branded thermal insulation material, I won't mention the names, but basically all of the thermal insulation material, branded ones, they use microfibers or hollow fibers as the basis of their thermal insulation technology. And Heatmax took a totally different approach. So microfibers, basically what the idea is based on is that it creates smaller sizes of air pockets, which will make thermal efficiency more, thermal value a lot more efficient in terms of conserving it. And they also use hollow fibers, saying that we contain air inside our even own fibers. Therefore, it is more thermally efficient. Now, our approach, Heatmax's approach is totally different. We don't use microfibers, so you don't see those really, really tiny fibers. You don't see hollow, empty space in our fibers. Now, why do we do that? The idea that we have, or realization that we have, is that these microfibers and hollow fibers do not provide sufficient strength to create the maximum volume or structural integrity to make the thermal insulation material. So if you actually think about constructing a building with wood or concrete and steel, because of the weakness of wood in comparison with the concrete and steel, you would not be able to go much high, many stories with a wooden structure. And it is the same approach or realization that we have. Microfibers were developed more than 40 years ago. In fact, when I was at the college taking the textile engineering, it was sadly more than 30 years ago. But even at that time, my professor was teaching us about the hollow fiber used in the artificial heart to carry the blood around. So it's not a new technology; it's a very old technology, and the industry has been using these to create the notion that microfibers and hollow fibers are more thermally efficient. Once again, we took a different approach. So we actually calculated how much of air does the hollow fiber create versus how much do you lose in volume. And so when you have a volume like the really lofty thermal insulation material, you can say that 90% is air, basically 10% of the fiber. So 10% of the fiber, and even if hollowness, the empty space in the center takes up 50% of the volume, it only gives you 5%. But if you lose that much or more of the volume that you see here in this thermal insulation, then you're losing more than you gain. And so that has been our approach. So if you think about having two bottles of beer, and the one has a smaller bottle neck, and the other one has a slightly larger bottle neck. However, it will take longer if the bottle itself is much bigger than the smaller bottle. So that has been the philosophy of our approach. And it is called NMF technology, no microfiber technology. And of course, we use proprietary fiber technology to maximize our space. And not only that, if you think about using weak fibers like microfibers or hollow fibers, it would not recover from compression very easily. So compression resistance, if it's low, then you will lose the air pockets that you created. Plus, if you use weaker fibers, once again, microplastic contamination will become a really, really big issue. I will cover this tomorrow at the YouTube live streaming, so please join us because you're going to see some shocking numbers tomorrow with regards to microplastics and how much that comes off of a textile goods. Now, our approach has worked. And with no microfiber technology, if you look at the test data for each weight category in comparison with brand A, brand A is most well-known thermal insulation material in the market. It's not the most expensive, but I use brand A because it's most balanced material in comparison with any other insulation companies in terms of microfiber, portion of microfiber versus regular fibers. So if you look at the claw comparison between brand A premium product versus Thinsulate in every category, we've outperformed by at least 15 to 20%. And if you look at the 250 GSM, 300 GSM, 300 GSM, for example, it gives you almost 8 claw. So what that means is that you actually put on the men's suit attire 8 times over. So the weight of the total weight of 8 times over of that men's suit would be close to 20 kilograms. But we can offer equivalent warmth only with 300 GSM without using microfibers. So that's the importance of it. Now, down feather, sheet down, and weather repellent down, I'll cover it really briefly. It's a really big subject. In fact, I will have last year during the height of the COVID-19, I had one webinar which talked about the issues of down feather material and how we can address it with our patent pending I-down and down technologies. I will do it again in coming weeks, and I will communicate with you. So it is a big subject. I will just cover it really, really quickly. Now, sheet down, this, when I saw this product, I was shaking my head. Why is this needed? Maybe I should not say shaking my head, but I had a big question in my mind. Why is this needed? If you look at the value of down material, clear power 550 versus 900. Okay, there is a price difference of easily 10 times. Why? Because given the same weight of the down feather material, it gives you most volume. Most volume created by the air pockets. So the presence of air pocket is such an important factor of using down feather material. But why would you compress it? Compress it in such a way that you lose all, like when you buy a banana from a grocery store, it's as if you just peel off the banana and throw away the inside part of it, and you just keep the skin of it. It seems to me it's almost like that. Why would you do that when you can create so much, the quantity of air pockets so much easier with conventional ways of constructing thermal insulation material? And it would be so much cheaper. I could not believe how expensive this material is, yet in terms of the thermal value, it would not be the most efficient thermal insulation material. I have to say why, because there are so many issues of using down feather. Now, down feather issues. Now, the down feather, along with the animal fur, down feather has been used by mankind for thousands of years as a thermal insulation material. We've always had this problem of down leaking. And I saw a gentleman in front of me at a coffee shop, and he was full of the down feather, and I took his permission to take a picture. And if you actually blow it up, there's so many pieces in this jacket. By the way, it was not a cheap jacket. Also, microorganism and odor. A lot of people don't realize it, but if you have garments or duvet covers with the real down inside, I don't have to open them because I know that there is microorganism living in there. Why? Because our body creates food for bacteria. And urea, fatty acid, and a lot of other body elements that comes out of your skin is food for bacteria. So there is microorganism, and how dense it is and what kind it is, depending on that, you may be able to smell it, you may not be, but there is a presence of microorganism. And the clustering and cold spots, and the cold spots coming from the garment constructions. And also, when the down is faced with high humidity, that's what happens here. You can see the synthetic material, dry versus wet, it doesn't change the volume, but the down, it loses its volume so much, so it creates huge cold spots. And chemical treatment has been really, really bad in the down feather industry as a whole, and difficulties in maintenance. All of these issues are associated with down feather. So if I just give you a quick snapshot of down feather versus synthetic, of course, down feather has advantages of having a luxury image, light and warm. However, this is only when it's in the optimum state. And when in a wet weather, synthetic would perform better than that. And in fact, as a person who has been in the thermal insulation material, I do not own any item with the down feather because I know that it has to be maintained really, really well. When I say really, really well, the frequency of washing and cleaning, and how you keep it, and all of these factors, it's not something that I can maintain. So that's why I chose to have non-down items in my closet. Anyway, there are a lot of different comparisons that you can make, but one thing that is important for me to mention is the down feather is performing best at its optimum state, and a lot of other cases may not work. And also, this is experience that I've had with some of my customers when I go and visit, and before pandemic, of course, I talked to them about down leak, and a lot of my customers would say, "Oh, you know what? We use a lot of we use good down bags, and we don't have this issue." However, that is not the case in a lot of cases, because Amazon is full of negative comments about the down feather poking out or stings, or the last one that you see is she loves the jacket. It's cute and she got a lot of compliments, but down feather leaks. So this is a major problem. In fact, when we do another round of webinar for our patent pending I-down and N-down technology, we'll show you how we perform. In fact, I think I included a short passage of that before we end the presentation. Now, water repellent down. I know this has been used in the industry, but what about the durability of it? How many times can it stay? It relates to toxicity of it. In fact, there has been a bit outcry about the use of the C8, C6 as a water repellent chemical agency. And so most of the advanced countries banned this material. However, it is still used in many other countries out there. And C6 and C8 continually contaminate our water systems. And what about the price? So is it really worth it? That's something that we really have to seriously think about it. And we have patent pending HIMEX technologies called I-down and N-down. We address most of these big issues with our patent pending technologies. It's a bag technology and it works really, really well. Now, I want to also present the aspect of real life warmth. So let's say you are using the best possible material, high flow value, high field power. Is it guaranteed to produce warm product? So you start with this good material, and you may go as far as testing your garment with the average flow value or whatnot. But let's look at this scenario here. When the cold air hits the thick part here with abundance of air pockets, a lot of wool will be filtered and it goes through a small portion. It can be compensated with the heat energy your body creates, so you don't feel cold. However, if it hits cold spots like this, meaning stitchy areas, basically there's no filter through. So the cold air comes through, and your body is not built to say, "Oh, my skin," you should calculate the average of the cold air coming in through here and here, and then you should feel the average value of it. It doesn't work that way. And that's why the cold spots, analyzing the cold spots, is really important part of real life warmth. The funny thing is this: most people will depend on their purchasing decisions. They say, "Oh, I spent $1,000 to buy expensive winter jacket, and it's wonderfully warm," while they overdress themselves inside. Most people are like that. There have been some really objective people who say, "Oh, I spent $2,000 on this jacket, but I'm still cold." Now, that's because of these cold spots. And so if you look at base material versus how the finished goods are, and you can see the cold spots in yellow and red spots, and you can see how much clustering is happening, how much cold spots are created. And this is a really bad example of clustering here. You can see virtually like in order to prevent the down leak, they actually do the seam sealing and this ultrasonic bonding, I should say. And this creates a huge cold spot, yet, there is a clustering. So this would not be a warm jacket. No matter how much money that you spend, this would not be a good one. Now, quickly about thermal heat max technologies, we have taken totally different approaches, as I mentioned earlier. And if you have product A and B, and the product B performs 10% better than product A, then you would consider that as a good performance. However, because of a totally different approach that we have taken, we have been outperforming the most competitive, most performant brand in the market by 300 to 400%. So this is really a breakthrough technology. And if you look at our approach versus typical industry approach, where raw material, the optimum quality indicator of the raw material is the key decision making, but HeatMax's approach is the superior performance on the finished goods, not the raw material itself. And if you look at the thermal imaging on the left versus right, our patent pending end-down technology offers much more improved performance. And basically, we measure the surface temperature of these pillows. And our end-down technology contained the temperature as much as 3 degrees Celsius. In fact, with a different structure, we can have even more than that. So that means it can conserve the heat energy by almost 3 degrees Celsius. If you think about heating your house by 3 degrees more in the wintertime, that will give you hundreds or even thousands of dollars more in electricity bills. Flow value 52% higher, and the heat distribution is much more even because of our patent pending technologies. And this might be one of the easiest ways for you to understand so down leak. If you are in the down industry, basically down leak has been an issue for thousands of years. And the IDFL, this is done by IDFL, not HeatMax internally. And they did the downproof test, and what they told me is whether you test the most expensive down jackets or the really street brand, mostly before 3 washes, you get level 2 or 3 in the rating scale. After 3 washes, it comes down to 1 to 2. And when they tested our iDown, we have iDown with the 2 levels, level 1, level 2. In this case, it was level 2, which gives higher protection performance. And we got level 5 in both before wash and after 3 washes. And they put, this is remarkable based on their experiences. And then after this test, I asked them to do 50 washes on our level 1 product. And they had never thought about doing 50 washes because that was unthinkable in the industry. Now, with the level 1, we got 5 and 5 after 50 launderings. It's the first ever in the industry, and also we actually did up to 100 washes, and that we still got level 5. If you would like to see any of these reports, we have it available. We can share it with you. We had one valuable experience along with promoting our iDown end-down technology. One brand came to us and said, "Oh, we're interested. Okay, so let's make samples and evaluate." Now, this is what happened. In the course of blowing, the blower was so strong that it was damaging the integral structure of our non-woven fabric. So it failed. In fact, it created more leaks than conventional down bags. However, I have visited many manufacturing facilities, and that there are many factories that are properly set up, including those in Korea, Canada. You cannot blow your blower that strong, because if you look at the down feather under a microscope, they're so delicate, they're so small in terms of hair, and these small hairs. It essentially gives you the performance. But if you have such a strong blower, not only if it can damage our non-woven structure, imagine how much damage that it will create for these delicate materials. So, so at that time I communicated with the brand. Okay, you know what? Our system is not created to endure such a strong blower. But if you do use this type, if you continue to use this type of blower, your garments will be full of dust from the down feather. Anyway, so our end down technology has a special cold spot relief technology. Basically, it can give you flow value 1.05 or higher in even the stitched areas, which is really good protection against. And I did this analogy because one of my footwear customers came to me and said, look, with the previous insulation material, we had the label that says 200 GSM, and that's a really important quality aspect that we appeal to the consumers. While with HeatMax, we can match or exceed thermal performance of competitors 200 GSM with only 100 GSM. So their concern is if we post 100 GSM, consumers think it's going to they're going to think it's going to be underperforming product. However, we have to update our knowledge level when it comes to thermal insulation. Because thermal insulation goes inside, nobody sees it. The technology has been outdated for several decades. So if you say, I'm going to judge the quality of thermal insulation based on the weight of the thermal insulation, it's as if you're saying that all the clunky vehicle with a really large fuel tank is better than new vehicles with cutting edge technologies with small fuel tank, but it comes with so many other performance features. And we have a lot of performance features over and above the superior thermal efficiency. And it depends on which product that you choose, but we could not even put all the logos in one page. And we also offer significant environmental and social responsibilities. Tomorrow in the YouTube live streaming, we'll focus on the greenwashing being done in the industry, which is really bad in my opinion. And also we're going to talk about clean recycling initiative. Once again, I'd like to emphasize that education is available and a lot of wrong things are happening, wrong activities and false claims, and these things are happening in the thermal technologies in the industry. And I hope that you in the industry are not the drivers or will not be the drivers of these wrong campaigns. And therefore, I think education is really important. If you'd like to have your colleagues involved in organizing these sessions for whatever reasons there might be, please feel free to reach out to us and I'll be more than happy to help you and your organization. Once again, my name is Say, and you can contact me to the emails or phone number is listed here. I would like to thank you very much for your attention. It's almost the time, but has there been any question, Kenya? Okay, so there has been no question. Obviously, you can contact me via email or phone or any other means if you have any questions. But one thing that I'd like to communicate is that in the coming weeks, I will announce more webinars and YouTube live streams, and hopefully you can join those sessions as well. Once again, thank you very much for joining and have a good rest of your day. Bye.